Hello and welcome. In this video, we're going to talk about partial derivatives using chain rule. In previous videos, we've looked at an introduction to partial derivatives. We've looked at partial derivatives using product rule. We've also looked at partial derivatives using quotient rule, and we've solved some questions on this. I'm going to leave the links in the description below. All right, without wasting much time, let's go into chain rule. Okay, we have a question here. If z equals sine 3x plus 2y, find partial z, partial x, or differentiate the function partially with respect to x, and differentiate the function partially with respect to y. So when we're pronouncing this, we could pronounce it as partial z, partial x, or del z, del x. Alright, so looking at this function, this is a multivariable function. Why is it a multivariable function? It is a function of x and a function of y, and that is why we're differentiating partially. Okay, so looking at this as well, we can see that it is a function of a function. We have a function 3x plus 2y, that's a function, and then we have another function which is sine 3x plus 2y. So we have a function of a function, and that is why we're applying our chain rule. Whenever we have a function of a function, we apply our chain rule. Now, the fastest way to use chain rule is to differentiate the inner function. If I have sine 2x, to solve this, if y is equal to sine 2x, I want to differentiate it. This is not a multivariable function, so if I want to differentiate and find dy dx using chain rule, I'm going to differentiate the inner function, right? When I differentiate 2x, I'm going to be left with 2. And then I'm going to differentiate the entire function, which is the outer function. So I'll differentiate it as a single function. So when I differentiate sine 2x, whenever I differentiate sine, you have cos. So I'm going to have cos 2x. So the derivative is 2 cos 2x. And that is exactly what I'm going to be doing here. So to differentiate this function partially with respect to x, I'm going to differentiate the inner function partially with respect to x. So differentiating with respect to x, I'm going to keep y constant. Alright, so when I differentiate 2x plus 3y with respect to x, I'm going to have 2. When I differentiate 3y, I'm going to have 0 because y is a constant. Whenever you differentiate a constant, you have 0. So I'm left with 2. And then I'm going to now differentiate the entire function as a single function. And that will be 2 multiplied by cos 2x plus 3y. Very simple. So my partial derivative with respect to x becomes 2 cos 2x plus 3y. Very simple. To differentiate partially with respect to y, partial z, partial y becomes differentiate the inner function partially with respect to y. Keep x constant. When you differentiate 2x, you have 0. When you differentiate 3y, you have 3. Multiplied by differentiate the entire function, that becomes cos 2x plus 3y. And this becomes 3 cos 2x plus 3y. Very simple. Very simple. Let's look at another example. Alright, we have another beautiful question. Z equals x squared plus y squared all squared. Find partial z, partial x, and partial z, partial y. Alright, so to differentiate this function, you can also observe that x squared plus y squared is a function. And x squared plus y squared all squared is another function. So we have a function of a function. So we are applying our chain rule. Alright, so apply your chain rule. You differentiate the inner function. Alright, so we want to differentiate the function partially with respect to x. We differentiate the inner function partially with respect to x. When we do that, we keep y constant. So whenever we differentiate a constant, we have 0. Okay, so this differentiating this becomes 0. Differentiating x squared becomes 2x. Alright, now we'll differentiate the entire function. So in order for us to differentiate the entire function, we're going to remember that whenever we have ax raised to the power n, to differentiate this, we multiply the power by the coefficient anx and subtract 1 from the power. Alright, so that is exactly what we're going to do here. The coefficient is 1, so multiply the power by the coefficient, that becomes 2, and then you have your question x squared plus y squared, and subtract 1 from the power, 2 minus 1. Alright, so this becomes 4x into x squared plus y squared, and that is it. Very, very simple. Now, to differentiate the function partially with respect to y, we'll go through the same process. You keep x constant. When you differentiate a constant, you have 0, so this becomes 0. When you differentiate y squared, you have 2y, and then you differentiate the entire function. Multiply 2 by 1, that is 2. You have x squared plus y squared, subtract 1 from the power, and you have 4y into x squared plus y squared. Very, very simple. Alright, I have a couple of questions here for you to get your hands dirty, solve them, and let me know your answers in the comment section. Thank you very much for watching. Don't forget to like, don't forget to share this video to your classmates and friends, and don't forget to subscribe. Goodbye.